When we talk about dynamic routing protocols, we're basically talking about two categories of protocols: interior gateway protocols, IGP, and exterior gateway protocols. But when we're talking about routing protocols, we're basically talking about protocols that are used by the routers talking to each other now on a network. Now, pay attention. There's a difference between a routed protocol versus a routing protocol. A routed protocol is a protocol like TCP, IP, and so on. But routing protocols are protocols like RIP version 2, IGRP, EIGRP, OSPF, ISIS. In the interior gateway routing protocol, and the exterior gateway routing protocol is border gateway protocol. Right? RIP is routing information protocol, and there's a version 2 of it because RIP is the oldest routing protocol in the book. IGRP and EIGRP and IGRP are Cisco proprietary protocols. Cisco developed those protocols. However, for the CCNA exam, we're only going to focus on the EIGRP, EIGA protocol versus the EIGA protocol because this is no longer being tested. OSPF would both be for the CCNA as well as the CCMP. ISIS is for the CCMP and BGP is for the CCMP. Right? But for the sake of this class, we'll be focusing only on RIP. Alright? But we will talk about RIP version 2, EIGRP, OSPF, and ISIS now. So again, when we talk about routing protocols, we're talking about protocols that routers use to talk to each other routers to get information. Now, I did take the liberty, instead of reading that long lesson on the Cisco labs, I decided to do a summary of the importance in terms of the difference between dynamic routing protocols, which basically comes into distant vector, and link state protocols. Distant vector protocols we discuss in terms of RIP, which is basically the oldest routing protocol in the book. Right, and we're going to discuss why this protocol has been enhanced by RIP version 2. But for the CCNA exam, you still need to know what is RIP. Right, IGRP and EIGRP, EIGA and IGA, those are protocols that are Cisco proprietary protocols that developed by Cisco. Link state protocols, ISIS and OSPF, and we're going to talk about the OSPF in terms of open shortest path first. A very complex routing protocol. Again, if you go to the other line, you see these distant vector protocols. Routers communicate with neighbor routers. This is the whole concept of the distant vector routing protocol versus the link state protocols, where these protocols like OSPF and ISIS, they have a complete topology of the entire network now. Right? Whereas with distance vector, they communicate with their neighbor routers in order to get routing information and so on, and as well. These distance vector routing protocols use measures of distance and vector. We're going to talk about the concept of distance and vector. In terms of distance equal to metric, we're going to see a chart that I'm going to show you all in a little bit. That metric meaning hop count. We're going to discuss that. RIP uses hop count, and RIP version 2 as well. And vector, when we talk about vector, we're talking about which interface in terms of the direction in which interface that these protocols will be going out of now when they're communicating with neighboring routers and so on. Whereas with link state protocol, they use the connections in terms of the links, and we know with links it could either be up or down. Link state protocols requires, as you can see here, advanced knowledge of in terms of convergence time is crucial. And when we talk about the whole concept of convergence, is that for these larger networks, when a link go down, is important for that particular network that is configured using either OSPF or ISIS, could understand the concept of finding out which is the best path would be used in order to get to a specific location or something like that. Whereas distance vector, they use like non-hierarchical networks like a hub and spoke. networks, which requires minimum administrative knowledge in terms of convergence time, is not an issue. When you talk about the whole concept of convergence in terms of when a network gets to know about all the other networks within that particular domain. For example, with link state, if a link goes wrong in a particular network, the network would converge as quick as possible by sending out triggers, objects to take into consideration that these links are no longer available. So it means then that it will be easier for the network not to send packet information and so on to that particular link that is down now. So hence the reason why convergence time is crucial when it comes into to larger networks that are hierarchical in nature and so on. Whereas again for distance vector hierarchical non-hierarchical networks like hub and spoke networks and so on, and again convergence time is really not an issue because they get the information from neighboring routers and so on, right? Knowledge of the networks, for example, they gather that from the neighboring routers, from directly connected neighbors and so on. Whereas link state, they have a complete knowledge in terms of the entire topology of the network. Now, as with link state protocol, they have like, you know, they know everything in terms of which network would go down, where is the best path to go here and so on. Right? With link state protocols, they use what you call trigger or partial updates. And of course, when we look at the other table, we're going to see where the distance vector routing protocols use periodical updates and sometimes send the entire routing table. Right? So again, if we want to look at the various characteristics, we could see it here that in terms of RIP, and we're going to talk about the concept of administrative distance versus AD. What it means. AD means the trustworthiness of that particular link. For example, RIP being the oldest routing protocol in the book have an administrative distance of 120, and we're going to see that when we do a video in terms of the whole concept of the trustworthiness. Whereas OSPF has a trustworthiness of 110, EIGR have a trustworthiness of 90, and of course this is Cisco proprietary protocol, so it was obvious that 90 would be better than RIP and OSPF. And if you configure your network static, it will be 1. And directly connected networks are 0. So the lower the administrative distance, they mean that the higher the trustworthy of the network. So for example, if you configure static route, it is going to, it's most likely the packet is going to route via static routes first versus RIP, because RIP have a higher administrative distance of 120 now, meaning then that the trustworthiness is least to a static route. And a dynamic connected route, in terms of directly connected routes, the administrative distance is 0, because of course they are sharing the same router information, so their trustworthiness will be much higher. And why static routes are administrative distance are 1, because these are administered by the administrator. So it's only obvious that if the administrator administer these type of networks by setting up static routes, the administrative distance in terms of the trustworthiness would be 1. EIGR, OSPF, RIP, and RIP version 2, these are dynamic routing protocols. These protocols use complex algorithms and so on. We'll talk about that in a little bit. So the administrative distance in terms of the trustworthiness would be less than static or directly connected routes. When you talk about the concept of metric, RIP uses hop count in terms of the number of hops it will take to get to a particular network. So if it means then that if you use a trace route command, it means then that it could tell you how much hop it will take for Alice to get to Bob. It means then that if Alice will take 5 hops to go across to get to Bob, the hop count would be 5 in this case now. Alright, so when we look at metric as well, we look at the OSPF that uses a concept of cost in terms of bandwidth. EIGR as well uses bandwidth, low delay, reliability. They use also MTUs and so on, which I didn't put on the chart here, right? But when you read the Cisco lab, you would have come across the MTUs and so on. But the concept of bandwidth versus hop count and so on is that with RIP version 1 and 2 or EIGR, for example, which EIGR will use bandwidth over RIP, because for example, RIP because of the algorithm, it uses the shortest path in terms of to get to that particular network. So even though if it might take at least 5 days to get to Bob, and Bob link is only like about 3 hops alone away, right? It would not use this concept of bandwidth. But EIGA now, EIGA could probably be implemented in such a way that if it takes 5 hops or 10 hops to go to Bob, it will take those hops instead, because it will take into consideration the bandwidth. So for example, RIP would rather take 3 hops that will take 5 days instead of taking 10 hops that will take only 6 minutes or 6 seconds or something like that. Right, so I hope you all understand the whole concept of hop count versus bandwidth and so on. So again, RIP will take 3 hops because of the fact that it counts by hop counts, versus EIGA that uses bandwidth, right? And again, if it takes 10 hops to go across in terms of bandwidth to get to Bob, and it only takes you 6 seconds, RIP would rather go and take 3 hops alone that will take it 5 days and so on. Right, so it does what they call periodic updates using the broadcast multicast in terms of and these are some of the numbers that you would need to know for your CCNA exam, not for the end of term exam that we're doing here. In terms of the multicast will be 224.0.0.9 for RIP version 2, the multicast address, and the multicast address for RIP version 1 uses the 255.255.255. Right, all of them uses trigger updates, and when we talk about the concept of trigger updates, for example, RIP sends out their entire routing table, right, to neighbor devices and so on. Okay, however, it doesn't do partial updates. However, OSPF and EIGA does what you call partial updates. Trigger updates in terms of like every 30 seconds and something like that would send out a trigger to make sure, to let his neighbors know. In this case, for RIP version 1, OSPF of course is link state. It will send out trigger updates every 30 seconds and so but these trigger updates will be partial updates. For example, if a link goes down, right, it will send out that particular information alone that is needed for the network, that this link A has gone down and so on. With RIP version 1 or 2, it doesn't do that. It will keep on sending out its entire routing table now, and so on. For VSLM, which you would pick up in Network Management 2 and the other classes, RIP does not deals and treats with subnet mask. And when we do the video exercise in terms of how RIP version 1 operates, it does not send a net mask. So in terms of variable length subnet mask and so on, that will be an issue. Hence the reason RIP version 2 deals with subnet mask, and OSPF and EIGA also do it. The types of algorithm that are used, Belmont Ford. Alright, this is just information in terms of if you want to go further into your IT career. RIP version 1, RIP version 2 use the Belmont Ford algorithm. OSPF uses Dirksch's shortest path first, and OSPF is a very complex algorithm. In fact, I have a book that is about like this thick. You understand? Real big. Just dealing with OSPF alone. Alright, and EIGA uses the dual algorithm.